I'm going to talk about using Rubocop for fun and profit. My name's Alex. I work at Unbounce. You can follow me on @McTaylorPants on Twitter. So what's Rubocop? Who's used or heard of Rubocop? Awesome. Nice. Okay. So for those of you who maybe don't know, Rubocop is a static code analyzer for Ruby. And usually it's used for enforcing style guides, so making sure all your style is consistent, but it also has autocorrect, which I don't know how many people know about it. I think it's pretty cool. Not this autocorrect. It's much better, much cooler. So let's say you have code like this, which maybe your developer who's tired just left this in a mess. It works, right? With Rubocop autocorrect, you can magically turn it into this with no effort on your part. Pretty sweet. And all you need to do is just append -- autocorrect when you run it in the terminal. And it'll do this for any cop that has autocorrect, which is pretty sweet. And so I kind of heard about this from this blog that Shopify did when they recently upgraded from Rails 4 to Rails 5. They actually dual booted. So they had all these if statements in their gem file or in their whole code base where they would look at an environment variable and decide whether to run Rails 5 code or Rails 4 code. And so needless to say, they had tons of this throughout their app. When they were done, they just wrote a custom cop to autocorrect this away and just keep the true branch of the conditional and remove everything else without needing to go through everything. So I thought I could just give a quick crash course on using autocorrect and writing your own custom cops by kind of doing what I consider is the hello world of Rubocop, and I'll show you what I mean. So let's say we have a bunch of logger lines through our app to log various things to sumo logic or something else. And we want to manipulate the text in each one of these. So we just want to change the string somehow. So I hope you can see that. That's a little bit small, but this is the general shape of a cop. Everything is under the Rubocop cop namespace. And then you've got a test or another module, which is the department of the cop. So you can group similar cops under a department, following with the cop analogy. And then you've got your name of your cop, which of course inherits from the normal base cop. And then you've got this message constant, which would be the string that shows up when you run Rubocop and this cop detects an offense. And then you have an optional or one or more number of these methods which tell Rubocop when to trigger this cop. So, and here I want to trigger it every time it detects a method call when it's parsing my code. So I'm going to use onSend, and onSend just receives a node, which is like the Rubocop representation of the thing in the AST and computer science and all that. So how are we going to implement onSend? Well, we want to basically replace anything in those strings anytime we call a method on logger, on Rails logger. So we're going to receive the node, which is info. We're going to look at its receiver, which is logger, and make sure that the method name is logger. And that way this cop will only execute under these conditions. And then if we find that, we can add an offense to the Rubocop kind of registry. And we can use the selector option to say, basically highlight the exact column row of the string that we found. So now we're going to implement the autocorrect method. So the autocorrect method is the one they actually get to run when you do -- autocorrect. If the cop detects an offense, it'll run autocorrect. And it's just a lambda, which receives a corrector object, which is the Rubocop object that actually does the manipulating. And from there, we can use the replace method to look at the node, get the arguments, get the first argument, get the location of the argument in the file, and then finally get the expression, which is basically like the range of columns that you want to replace. We're going to replace it with hello world, because who doesn't want to do that? So now we can replace all of our log messages with hello world and confuse all your fellow developers for fun and probably not profit. So just to see this in action, we have all these log messages. We run autocorrect, and now we get all these log messages. And suddenly you have no more errors in your application. Isn't that great? So a couple other things to note. Obviously, you can use the autocorrect flag. When you're developing cops, you might just want to stick a Ruby file in your desktop or whatever. You can use the require flag to include it automatically without having to deal with adding it to your project. And then you can use the only flag to say, when I run Rubocop, I only want to execute my cop. I don't want it to run any of the normal linters. So it's good for debugging. Thanks, everyone. and enjoy the rest of the lightning talks.
Hey, I'm Teague. This is kind of my last minute lightning talk, so sorry if it's a little rough. So I want to talk about GraphQL. My name is Teague. I work at Kickstarter in New York, and I work with Philippe. So thanks to Philippe for inviting me and my coworkers, Jake and Daniel, out tonight for meetup and pizza. And I kind of want to talk about like why use GraphQL. It's only 2 years old and it's getting a lot of attention right now. So I kind of want to start out with like, actually, oh shoot, how do you go back? There we go, okay. Who's like heard about GraphQL or read a blog post or seen a talk or like tried it themselves? Okay, cool, there's a lot of context here. Okay, so I guess I'll start with some background, why we chose to use GraphQL in our Rails API. First of all, you have Rails, which is a 12-year-old framework. It's great, we love it. It really excels for like small apps and prototypes and like JSON APIs, which people have been using it for lately. Then you have GraphQL, which is like this 2-year-old hyped up API spec that came from Facebook, from their years of experience and scale. And then thirdly, you have Kickstarter, which is, we have a 9-year-old Rails monolith that's been around for a while. There's a little tech debt and stuff in it. We're about 5 years into our JSON API, which we built for our iOS client. That's the reason why we originally built our JSON API. It kind of lives separately from our web controllers in Rails. And then we're also 10 months into using GraphQL, and it's going great, and we're having a lot of fun. So I just want to talk about why we chose to use it and make the leap from like a vanilla Rails JSON API. Okay, so just in a nutshell, for an overview, this is basically what GraphQL is. It's like you make a single request to a single endpoint. Typically, it's like a post request to like something like this path, and you send it like a data payload, which is the shape of the data that you want to get back from it. And then you get a response back, and you get JSON, which comes in exactly the shape that you wanted, unless there's an error. Okay, so given that, let's start talking about why we like GraphQL. So we had this problem with APIs, with our API, where we had multiple clients over time. Like we started with iOS, that's the reason why we built our API. And then fast forward to 2017, we have Android, we have the web, we have Ember, we have React, we even have analytics JSON that we use for our from our JSON API. That means that like once you change something in our JSON API, you have to worry about the other clients, and because they're probably using the same paths. And if you remove something or add something, it's going to affect all the other clients. So GraphQL's solution to this is there's pretty much like no need to worry about the client in GraphQL. You can insert the client data in client context into GraphQL and switch on that, but you don't really need to, which is awesome. It's like we don't even have to think about that in our GraphQL API, which compared to our old API, we just have like so many conditionals that are based on what's asking for the request. Second is serializer spaghetti. Like over time, we have 42 serializer classes, which serialize our models into JSON. We have 5 different sizes, which are totally arbitrary and relative. It's like some of them return 1 field, some of them return 10 fields. And then we also have these extra options for context that we pass in, like is the user an admin or something. And it just feels like spaghetti. It's like everything's spread all over the place. There's no consistency. It works, but it's hard to change. So GraphQL's solution to the serializer spaghetti is types. Okay, so first of all, you have types. Types represent your business models. And then the second part of that is that you can request a custom payload. So you get exactly the fields that you want back. You get exactly the models that you ask for back, and you don't have to worry about like this spaghetti of code that's all coupled together. The next problem we had was type uncertainty. Like in typical Rails serializers, you don't really have types. So you don't know, like, is this data I'm getting back going to be an epoch integer, or is it going to be like an ISO formatted date string? And so there's no standards that we really had. For requests, as far as requests, I love strong parameters. I'm glad that it's a default in Rails now, but it really feels like an afterthought to me. Every time I have to add it, it's like, it just doesn't feel like it's part of Rails, and it kind of removed the magic that Rails originally had with the attribute equals accessor. So GraphQL's answer to that is that the schema is a contract. So every field has a type. It discourages changes. So if you change something, it's harder than changing, calling 2i on some field in your serializer. This is kind of like what it looks like to define a type with a field in it. It's like super simple, very standard. And if you change that, you can tell like it's kind of a big deal. It's not just like adding 2s on something. The next thing that we liked about GraphQL, well, the next problem we had was fragile, unpredictable, and slow payloads. If you change one client's response, like maybe to your iPhone app, you have to worry about your other ones like Android and web and all those other clients. And as a matter of fact, like one of our slowest requests on our web pages are the analytics serializers, because we dump this analytics JSON into every page load and it's grown over time and we can't change it because we don't know what we're gonna break, which is kind of stressful. So GraphQL's solution to that is that you have the custom shape again. You don't need payload sizes. You get exactly what you asked for. The client can change that. You don't need to change that on the server. Do I have enough time, by the way? Okay, sorry. Okay, the next problem is serial requests. We have this case in our iPhone app where it loads a project request and then it loads the rewards to that project, and there's a third request to get the shipping cost for the rewards. GraphQL makes this so easy because you just do this in one request and it's just a nested JSON hash of models. Then there's URL bloat. You've probably seen URLs like this where you just keep on adding options to it. It's not the worst thing in the world, but it's just not pretty. GraphQL just makes it look better. It has a JSON shape and it doesn't look like a hack kind of. And then the next problem is documentation. Rails and Ruby developers typically don't worry too much about documentation. Sometimes we had RDocs, but unless you're like a really popular gem library, you're not going to spend a lot of time doing that. And it's even worse for Rails APIs, I think. So GraphQL solution is that you have schema introspection. So you can inspect the schema with a query like this, and then get that back and build like documentation on the front end, which is super easy and awesome. And okay, so finally, there are a couple more bonuses you get with GraphQL. Graphical, the client, if you haven't seen it, you should check it out because it's like the silver bullet for GraphQL. It's just this Node.js client, or it's a JS client that loads your GraphQL schema, and then you can browse it. It has a tab completion and all that stuff. Field aliasing is a really cool feature because you can request the same thing multiple times but give it different names. And the GraphQL Slack community is really good. It's really active. There's a Ruby channel for the Ruby client or the Ruby server. And there's also caveats to it. Like you're gonna have to rewrite a lot of stuff that Rails does for you, like nested attributes, and you're gonna have to worry about n+1 queries in a different way. But I think personally, it's been worth it for us to make those trade-offs. So, okay, and sorry that was a little long, but that's why we picked GraphQL.
So I'm Andrew, and for the last number of years, I've been maintaining this gem called IceCube, which some of you may know it, some of you may not, but it handles calendar scheduling for Ruby. So if you have a schedule such as something that occurs weekly or monthly, and you want it to occur on every second Tuesday of every month and things like that, it can create all these sort of schedules. So by maintaining this gem, I've learned a lot of quirks about time, and it's quite interesting about some of these things. So I'm just going to give you an overview of kind of the top 10 things that I thought were kind of interesting. So one of the things is, I think it's fascinating how we got to where we are about how we actually track time. So if we look back, originally it was based on solar time. So every location, whenever it came across noon, that was noon because the sun was up there, and that's all it was. So every village, every town that had a clock tower had its own time. Then the railroads came along and they had to be synchronized so that their trains wouldn't crash into each other. So you could actually come to Paris, set your clock to a certain time by the tower, walk into the train station, and your watch would be wrong by some minutes because the trains are running on a different time inside the station than outside. So eventually they standardized on UTC, and in computers, when we started recording this, it went from 1970 forward, and that's what we call the Unix epoch. It just started at 0, counting forward. And all of this information is actually on everybody's computer in a file called tzData. And it's actually quite interesting what kind of things it records. So in there, I think I'm jumping across slides instead of down into sub-slides. Is this like a spacebar or a right arrow? Okay. Okay, go back. Hit left. Okay, and just hit spacebar. Spacebar, that's it. Perfect. Okay, it's always someone, right? So there's things in there like, when does daylight savings time start and end? So there's records in there of when these things actually changed based on political decisions and things like that over time. So daylight savings time hasn't always occurred on the same Sunday of every month ever since 1970. Like, places have decided to change it on a whim. Like, this is, for example, the United States rules, which started out on the last Sunday, and then they changed it to the second Sunday, and then like, it's a bit of a mess, but it tracks all of this, and it's interesting because it actually makes you realize that time is not as linear as it seems. Like, it just kind of, our human representation of it changes. I clicked again. Oh, yeah, spacebar, good. So hit up for me for 1 sec, thank you. And the interesting thing about the tzData database is that it's written in a very literate programming style, so there's a ton of comments in there, and there's a lot of little quirky things in there that the researchers who went back through time and filled up this database with all of these decisions that people have made about what time they're going to observe in whatever region they're in. And so there's a bunch of things in there like this where, you know, after considerable debate, the decision was rescinded and the city reverted to sun time. A derisive offer to erect a sundial in front of City Hall was referred to the Committee on Sewers. Then in 1905, Central Time was adopted by city vote. So all these sort of little quirky things are actually inside the tzData database that tracks all of this information, and it's there as kind of like a chronology of all of this, all of these decisions. Another interesting one here is wartime. So this was actually a quote from a radio broadcast after the war was ended with Japan. So when the time is announced over the radio now, it is Eastern peacetime instead of the old familiar Eastern wartime. Peace is wonderful. Now, if you look at the Ruby code here, we run time.local 1945, August 14th, and we format the string for the %Z character, which is the time zone. We get PWT. And then you go a day later and we get PPT. So now, a lot of people think that you need to run Rails to get time zones in Ruby, but actually you can use the system TZ inside of Ruby, and you can use one time zone at a time without actually loading active support time. It just means that you have to deal with one time zone at a time, and you can't do things like zone-to-zone conversions. But it is possible to work with it one way or another. It just happens that Rails does a lot of magic for us to take care of this. But Rails can make it a little bit weird. So if you look here, you say date.today, we get the 24th of October. You say date.current, we get the 25th of October. Now this is because it's based on the Tokyo time zone, which I've set up there. So there is a slight difference like this that you need to be aware of. And for example, if you're doing daily reports based on the client's own time zone, you need to be aware of these sort of things. Another thing that's a common misconception is that time zones are not offsets. So an offset is simply, very simply, a fixed number of hours and minutes from UTC. So we are here in Vancouver. During the summer, we're -7 hours, and during the winter, we are -8 hours. Those are two different offsets, one time zone. And a zone is best represented by one of these identifiers that give the continent and then the name. There's an ETC category under which you find the UTC. But mainly, if you're trying to assign a time zone to something, these are the best identifiers to use. They include the current offset from UTC, historical rules for DST changes, so that whatever time you choose from one of these zones, the time offsets will be applied correctly for that zone, whether or not it's in summertime or not. I can show you after. That is also part of the TZ data database. It lists all of the different names for those locations in there as well, and Rails gets it from there. Then there's something that isn't really well defined, but I like to think of them as meta zones. So things like PST and EST, which is Pacific and Eastern Time in North America, and things like CET and CEST, which is Central European Time and Central European Summertime. It's always confused me that we get the S in winter and they get the S in summer. And the things about these is, yes, you can use these, but a few quirks about them is that the name and the abbreviation changes based on the time of year. So the identifier isn't very stable. It's convenient for display. Many people are very familiar with these. But the other quirk is that places that we think of as being in a certain zone can change zones based on political reasons. So if a border moves and suddenly they are in another country, then the zone of a certain city can now belong to a different offset. That shouldn't mean that they've changed zones necessarily. So it's always good to refer to place zones using the place name format. The other quirk is that zones rarely change together. So when your DST's rules are different from mine, so for example, in the UK, they change DST at on different weekends than we do here in North America. And so you're going to have a week, 1 week every year when those offsets are different. And a lot of people don't realize this. And it's very interesting for meetings sometimes. Now, there's these magic numbers that we as developers often learn off by heart. So you probably recognize these as seconds and minutes and hours and weeks and 365 days a year, but are they really, really fixed durations? So there's obviously, there's one thing that happens every once in a while. It's called a leap second, where because of the Earth's rotation, they will insert an arbitrary second, and the minutes at the end of the year will count up to 57, 58, 59, 00, and then go over to, actually, no, sorry, they count to 60 before they go to 00. So there's actually a 60 there. Now, I do wonder when they do the countdown on the television and people are counting down and it's a leap second, is that accounted for, and how did they get that into the broadcast? So now, twice a year, we have something that I would like to call a leap hour, because I couldn't find a proper name for this, but this is the second hour that you get when you wind the clock back. So days can have 23, 24, 25 hours. Weeks, because of that extra hour in one of those days, can have an arbitrary number of hours. So if you're trying to jump exactly by 24 hours, you might end up on the wrong hour of the next day, or conversely the week as well. Leap years, we know about these, but all of these take into account all the things beneath them. So leap years have to take into account leap hours and leap seconds as well. Daylight savings time, something that that a lot of people overlook, is that 2 a.m. happens twice in the fall because we wind the clock back. That hour goes one more time. In the spring, that hour does not happen at all. It gets skipped completely. So it's a good idea to know when DST is happening and to avoid running any kind of cron tasks around that time. And finally, London, even though the offset is commonly 0, it is not UTC. So this is something that that happens a lot, where people will see the time 00 and they will assume that it is UTC, when in fact that time zone will change between winter and summer time. Or sorry, the offset will change between winter and summer time. So especially when you're writing your tests, it's good to be aware of this and not use either your local time, which could be misleading to you that everything seems correct until it actually changes time zones when it's running in production, or using also London as an example, or UTC. So that's it. That's my 10 things about time.
I'm going to talk to you about 3 techniques for making your Capybara system tests more reliable and faster. I don't claim to be the guy who invented all these, but they worked for me. I took 40 seconds off a 2-minute test suite, so it was pretty sweet. Briefly, the problem is basically that depending on the driver you're using, your Capybara test script may be running in one process, the browser that it's driving is running in another process, and they're actually asynchronous. So you'll have, you can have a situation where you click link and it starts a get. While the page is loading, you go and grab a bunch of nodes off that page, thinking that you've already gone on to the next page. The page finally finishes loading, and then you start trying to use those notes in Capybara, or those nodes, those HTML elements, and Capybara says, these things aren't there, and gives you a nasty message. If you're lucky, that happens consistently. If you're unlucky, it like only happens on your dev machines, or it only happens on your CI machines, or it only happens like 1 every 10 test runs or something, right? So I see some nods. A lot of you know what I'm talking about. So it's not as big a problem, of course, as we think, because a lot of the Capybara methods retry for a certain amount of time to see that something comes up on the page. So something simple like just assert text for some text on a page, it'll sit there trying for a certain amount of time until the page is loaded and finds the text you're looking for and carries on. Okay, so if you do need to use something like although of course you get into some of us, and I'm totally guilty of this, start putting sleeps into our tests, right? Because we're just like, we've got to make this work somehow. And of course, now it works because you've arbitrarily delayed it. Of course, this is bad because it slows down your tests, it wastes time. And in my opinion, worse still, it starts to discourage you from running your system tests as often as you should. So the first trick or technique that I found, if there's nothing changing on your page, well, just put up a spinner, right? Like, or a loader, or some people call them, the thing that goes, something's happening in the background. And then, so I had this one test script where it was filling in a field. The field had an on change trigger so that it would run off and do some Ajax. And I needed to make sure that Ajax was done before I clicked the next one, before I clicked on that next link. So I just added in the JavaScript, just added it flips up a little div with a distinctive class on it. And when the JavaScript is complete, it takes it away. Now I can just write an assert no selector for that class. Capybara will do the wait thing with assert no selector. Boom, you take almost 2 seconds off every one of the test cases that you can do this on. Okay, the next one, when only the database changes. So you don't have any visible stuff on the front end, but the database changes. If I uncheck that box, I delete a record in a join table, right? So I want to make sure that's happening. So assert difference goes off and it evaluates the expression at the beginning, then it executes the block. I'm sure everyone, or most of us know this, executes the block, and then executes the expression again at the end to see if they get the expected difference. Unfortunately, the database might not have finished doing that delete, and so this isn't going to work. So you end up putting in a sleep again, or at least some of us. So what I did in this case is I just blatantly copied the code of the Rails assert difference and sort of basically just put that loop in. I had to do a little bit more hacking, but just basically put a loop in that every 1/10 of a second executes the expressions and gives up after 2 seconds. This could be done a lot better. If anyone wants to help me turn this into a real gem afterwards, we can do that. But, so now, whoops. Let's try that again. I worked for hours on these animations. We have to actually see them happening. Right? So assert difference now at the end of the block, it keeps trying. The last one is if only the order changes. So again, you're going to have the same stuff on the screen. It's a little hard to see what to catch. So I ended up putting in, I wanted to do the, you know, the oldest first, newest first, and then make sure it was working, and I needed to look at the notes. So I was trying to use all, and as I mentioned at the beginning, all is one of those that doesn't wait. So I built myself a little helper that looks for the text in a note body in the nth list item, if that list item happens to be a note. So it's a little complicated. That's the way the page was formatted. And now I can take out the sleep and replace it with a call to this helper. Two gotchas with this. One of them you can see here, right? The CSS pseudo class, they call it, is one based, and most of us are used to doing zero based. So I built that right into the helper. The other trick is that it's doing that counting just based on the HTML tag. So this does not get the first list item that's a note, it gets the first list item only. But if you keep that in mind, this can be a powerful technique. And those are the pseudo classes you probably want to know to do that. So that's it. There's a blog. I blogged about it as well, and that's my site and my email address. Thanks very much.
Hey everyone, I'm going to be talking about building server-side components in Ruby on Rails. I'm a front-end developer at Unbounce, and this is something that we've developed at Unbounce. I hesitate to call it a framework. It's more of just like a pattern, but maybe a pattern is a framework. I don't know. And yeah, I'm sharing it because we've had success in its adoption and its maintenance. So to start, let's see if this works. Oh yeah, nice. I just want to define what a component is. In its essence, it's a contract between a data and a view. I think of it as a pure function. Whatever you pass in X data, you're going to get Y view of it. And in its simplest form, which is what we use, it's just a Rails partial. We're just passing in locals. So let's take a look at how it works. So we have defined a single method in the application helper. You can see on line 2, we have namespaced it, named component. It takes 2 params. We have the component name and then a hash of options. No, I don't need that. I'm sharing this through Google Slides, through Zoom, so, you know. Yeah, so it takes a hash of options, and then we just render the partial and pass in the path. We grab the component by the component name, which we take it as a symbol, and it obviously goes into a string, or yeah, a string, and then we pass in the locals. I've also added a rescue so that if you accidentally type the wrong component name, you're going to get a helpful message that says, hey, you typed component A when you maybe meant component B. These are the options you've sent. So yeah, this is what a component call looks like. You can see we have the component modal header at the top, and that finds the path. And then we have the param, on this case, just title, and it takes the hash, passes it forward. This modal header, this is what the HTML looks like. You can see some of the ways that we handle the data. We take an ID param, we take the title param on line 2, and then there's some additional options like hide close button, which renders SVG. Following this pattern, you can actually create nested components. So that was kind of like the aha moment for me while I was building this. It was like, hey, I just made a component, and now when I want to define a component again, I'm just actually calling the same thing over and over and over. And it's really nice because, as you can see, it's just data again. We're calling the modal footer, and then we pass another component called write button, and then pass the label and the color in. And what this looks like, this is the modal footer. We're just making 3 calls to the namespace component, UB component. I wish that wouldn't do that. So why this is it's really nice because our composability is really simple. You can see just calling a component within a component is the same as when you call it outside of a component. And then your consistency in your front end and your UI increases incredibly because you've defined like a right button in one spot or a checkbox in one spot or a modal footer in one spot. You call it all over and over. So if you have a bug in that right button, it's going to show up everywhere and you're going to see it and you're going to fix it. Hopefully you don't have bugs in it. So then Rails is MVC. We think of the views as actually like, what did I say here? The place where you compose a collection of components. So this is the entire modal view. We have the modal header, which I showed you at the front slides, the modal footer, and the modal layout, all with data. There's no CSS classes. There's no HTML structure. We're just solely passing data through it. And it's nice because, again, if we want to change it anywhere, we can change it in one spot. And you can, if you need to make things look similar but need them to function differently, then you could just create a new component that's for a specific use case. And since this is just Rails, and it's just a Rails view, you can still use Rails helpers like on line 4, the form 4. So yeah, to jump back into some of the motivations of why we did that, we wanted to create simple, semantic, repeatable HTML structures. Copy and pasting sucks. It's really error prone. You might add a class where you don't need it. You miss a class where you do need it. It's boring. It's frustrating. We wanted to abstract the style classes. The team that I was on, I was the only front-end developer. And while I was developing all the classes and I could memorize them because I did it, it wasn't really fair of me to expect everybody else to memorize those. So I created components and they created components. We define it once and we'd actually never have to think about it again. As I said already, reduces UI bugs. You see a bug in one spot, you see it everywhere. Also increases the consistency in the same way. And it creates predictability. In our code base, the CSS was really old and it was, everything was absolutely positioned. So it created some very interesting use cases where people who were just learning how to use CSS would expect one thing and it wouldn't show up because it was being hidden by something else. This helped solve that problem a lot because they could actually develop their components in isolation and see how it worked. And then when they saw something not appear the way it would in app, they could either get me to help or they could identify, oh, this is actually just like an absolute position problem, and then identify the problem. Some best practices. So we've had this in app for 2 years, I guess, or so. And this is what we found is working really well. On naming, you should name everything the same. Name your component, the style sheet, the JavaScript files, all the same. This is especially useful for being able to delete a component because if you don't need it, just delete it and delete the 3 styles with it as well. It also makes it easier to find what you're looking for. So if you're looking for a modal header and it has special styling, you can just search for the modal header. We have actually included it in the app, not as a library outside of it, not as a gem, just strictly in the app. It makes it really easy to work with. We made a route / components. All the developers can see it right away. It has automated documentation. And it makes rewriting APIs, like if we wanted to change title to, I don't know, header title or something like that, you can actually just grep for it because it shows up pretty quickly. One of the most important things we found is you should keep components dumb. Only pass in data results. Don't pass in too much data. The component shouldn't know anything about your models. It should only pass in essentially strings because it's HTML. And yeah, for building one component at a time or extending the APIs, do those because if you try to build too much at once, you ain't gonna need it. And then writing documentations and schemas, test to enforce it. That helps just to make sure that the adoption increases and people know what you're trying to accomplish with your components. And yeah, I think that's probably the last point that I have. I'll probably turn this into like some sort of Rails gem at some point where it works kind of like RSpec, where it's, you create your own stuff. But yeah, if you'd like to talk about it or ask me any questions, feel free to find me afterwards. Thanks.
Emil Marchetta here. I'll be talking about the assert logged, and that's a GitHub repository with a small vanilla Rails application explaining and showing how it is used. It's basically a very, very tiny set of tools to integrate log testing within basic unit functional integration tests in Rails. I work in finance and payment processing, where the compliance auditing and logging is quite important. So logging is actually first-class deliverable. And basically, we need to share that with all the stakeholders and parties. So we basically being first-class deliverable, we integrated testing for it. So it's basically it's basically very small code, one Ruby module. It's not a gem, it's not a heavyweight, and follows a familiar assertion design, assert difference, assert select, and so on. So as you can see, what happens here's one small test. And by the way, all that code is available in that repo that I showed in the first slide, which it's basically a vanilla Rails application that has some bug management system. And this particular test should create a bug. It's creating a bug and making sure that with the assert logged statement that bug was successfully created. The assert log accepts regular expressions or strings or log levels, so can customize all this various level of filtering. Basically, how it works, it's at the beginning of the block and at the end of the block, it sets the markers within the log file, and basically it scans that log. It's very simple. Or it can assert that something has not been logged. So here is again from that repository an example. It's a model bug that logs some CRUD after events, after create logger info, and in a corresponding, we can see that in logs, log info bug was successfully updated, corresponds to after update callback. And here is again corresponding. This is created, but it's a corresponding assert log statement that MAD actually verifies that particular action. And here is a statement, assert log with multiple things, or should deny not permitted parameters that a colleague mentioned earlier. So basically, you can assert whatever you want in that particular log, whether with regular expressions or strings. Obviously, this is vanilla application. In real world, you have like IPs, users, and so on and so on. And here is how a failure looks like. Failures look like a normal Rails test failing, right? It's basically assertion. And a log entry should have matched regular expression, so on and so on. And yeah, that's pretty much it. There's not much more to it. It's very tiny. It's a very tiny tool. Here is the GitHub link. We have used this successfully for many years. It's not really a new thing, but I was working when you announced a meeting, so I said, okay, why not? So that's it.
All right, last talk on event sourcing, or like simple event sourcing. We had an event meetup on event sourcing about 6 months ago. Who was there? About 4 people. All right. Event sourcing in 5 minutes. Yay. All right. Let's start with the let's start with the quote. Martin Fowler says that event sourcing is that all changes to an application state should be stored as a sequence of events. So basically what that means is that you don't like instead of just mutating the data in database, you store an event and then you apply that event to the database. So let's take an example. That's an order like on an e-commerce store or something. So that's like order 1, 2, 3, and we can see that there are like 3 items. There are 2 pairs of socks, which means like 4 socks actually, and 1 t-shirt. And the status is that it's been delivered on, well, actually today. So that's like the current state, but the question is like, how did we get there? So the idea is that you will persist events to update that order. So for instance, the first event is that the user added like 1 pair of socks and then he added a t-shirt. And then the system displayed a promo banner on the website, maybe saying that, hey, you get your 3rd item for 20% off, and magic. The user after that added another pair of stock. And then he checked out, and then the system said that like the order was sent and that the order was delivered. So what's great about this is that you basically get tracking out of the box. You answer the question, how did we get there? How did you get to the current state? And so thanks to that, debugging is way easier. You get reporting for free, like you can know like how many people added an extra item after they've seen the promo. Well, you just get that. And also you get some sort of like a time machine. You can go back in time because you can just replay the events up to 2 days ago and see what the state of the system was 2 days ago. And you can, this one. All right, let's name things. So there are like basically 4 entities that we have to think about here. The first one are events. So we talked about them. So events can be like, hey, an item has been added, an item has been removed, the user has checked out, the order has been delivered, etc. Those are events. Then you have aggregates. So aggregates is basically the result of that sequence of events. It's basically your like day-to-day usual active record model. An order, an invoice, etc. And then you have calculators. So calculators are responsible to apply an event to the current aggregate. So let's say you have a blog post and the event blog post published just come in. The calculator will take that event and might just mark the blog post as published. It might just say like published at to the current time. And then, and that's the very nice thing about it, you have reactors. And so reactors will just react to events and perform side effects. They might send notifications out, or they might actually create new events. Like the one we've seen before is you had a reactor that was just like monitoring the cart and then figured that a second item has been added. And so it fired an event to then display the promo code. Oh my God, so that means that with all this, you can go crazy and you can go asynchronous because you can just like fire a bunch of events and then have like calculators that would just like apply those events and reactors just like listen to those events and everything can be asynchronous and everything can be distributed. But you get like a lot of complexity if you do that. And like looking into the literature or watching talks, it seems that a lot of projects that were like full steam, event sourcing, distributed, asynchronous, a lot of them failed because the complexity went just like through the roof. At Kickstarter, we are shipping a new product on November the 15th. Yoo-hoo! Which is in 3 weeks from now. And so we've decided to do that with event sourcing. And so we've decided to just go with synchronous event sourcing on the existing Kickstarter monolith so that we basically get like better tracking, debugging, reporting without a lot of extra complexity. We put together like I'll just go back. There are like 3-4 gems that implement like event sourcing. A lot of them go like very far into event sourcing. I just presented like those 4 entities. A lot of them will have like 10, 12 different entities. So I guess we are just doing like event sourcing 101 currently at Kickstarter. And so we've just like put together a very small framework that might be 30 lines of code to manage our events. So here is some code. Here is like an aggregate, like the post aggregate, and it's just a Ruby on Rails model. And then we have events. So each model will have, with each aggregate, we'll have many events. And so that's the event to update a title. So it takes attributes, here the title, and the apply method is actually your calculator that will apply the title of the event to the aggregate. And then there is like a bit of machinery to actually persist the post, but that's all we do basically. And here is the reactor. The content of the call method in the reactor is quite complex because it sends email with patches and stuff. But all we are really doing here is that we have this class that listens to an event, and whenever a post is published, it will send emails to all the people who should actually be aware of that new post. So that side effect is taken care of by the reactor, which also means that if we want to replay events to get back in time, we won't send emails again. And the last class below is the dispatcher. That's what will associate an event with a reactor. So the first one is basically, that's the machinery that we have when you create a pledge. So when you pledge to a project, an event pledge created happens, and that triggers a reactor that will take care of making the API call to Stripe to create a charge. When that happens, the reactor will create an event, which is the pledge was created on Stripe. And then you have another reactor that listens to that and will take care to send notifications and so on. So it's kind of reactive programming. Some people say that, and maybe it is. But so that's what we have so far. And so the last line here is like how we will hook the reactor that sends out that email notification when the post is published to that event. I think that's it. Oh no, that's not it. All right, let's talk about data. We've decided to go with like a simple approach, which is just to store events in the SQL database. And that's basically what we see when we look at our events in database. So those are like events associated to a post, the post 106. And so we can see what has happened over time to that post. You can see that the post has been created with a title and description. Then a media has been attached, and then we've updated the description, and then the post was published. Thank you.